Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Turning Cog by Timpanist, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have digits along the thermometer increase from the bulb end to the tip. So for example, if you could have something like 2, 5, 7, 8, and that would be valid as a thermometer because it's increasing from the bulb to the tip. What you could not have is something like 2, 5, 7, 6 because it's not increasing from this part here. And you must be always increasing from the bulb to the tip on a thermometer. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, what I typically do for thermometer puzzles is go from the bulb to the tip, looking at every the smallest possible digit, and then going back from the tip to the bulb, looking at the largest possible digit, and then filling everything else in between. But we don't need to do that here. There are certain columns and rows that are restrictive. Specifically, I see column 2. These digits cannot be 1 or 9 because they are in between two unique digits, right? Because these must be greater than this cell and less than this cell. Same with these. These must be greater than this cell and less than that cell, so therefore they cannot be 1 or 9. So 1 and 9 have to be here. Well, these two digits are less than this digit, definitely, so this cannot be 9, so 9 has to be here in this column, which means 1 is where? 1 can't be here because this has 3 digits smaller than it, so this must be 1 here. This is at minimum 4 because it has 3 digits smaller than it. That means, where's 2? 2 can only be either in column 2 here or here, which means there's a guaranteed 1 in one of these two cells. We're not sure which. So this has to be 4. Okay, so this could be 2, 3, 4, 5. This is 8 at most, 7 at most, 6 at most, 5 at most. So this is 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8. Where can 1 be in row 1? Can't be here because they're between two other digits. They're greater than this digit and less than this one, so cannot be 1 here. So 1 cannot be here because this is greater than another digit, so 1 is one of these two. Where's 9 in row 1? 9 cannot be here because of 9 in the box. These are less than a digit, so they cannot be 9. This is less than a digit, so it cannot be 9. So this must be a 1-9 pair here, which eliminates 1 and 9 in the rest of the box, so none of these can be 1 or 9. Where is 1 in column 8 then? Can't be here because they have digits that are smaller than it. Can't be here because of the 1-9 pair in the box. These two have digits smaller than it, so it cannot be 1. So 1 has to be here. Okay, so where is 1 in box 8? Can't be here. Can't be here because they have digits that are smaller than it. So 1 has to be here, which means this cannot be 1, which means this can't be 2. So where's 2 in column 2? It must be here. So that's 2, that's 1. Where is 8 in column 2? It can only be in one of these two cells, which means 9 has to be one of these two cells. Okay. 1 cannot be here, here, or here, so we have, and 1 can't be here. Where's 1 in box 7? It must be there. 1 can't be here or here. 1 can't be here. 1 can't be here. Where's 1 in box 2? It must be one of these two. Okay. This is at least 2. Where is 9 in column 8? Can't be here because of the 1-9 pair in the column. These have digits greater than it, so do these, so this has to be a 9 here, which means this cannot be 9 here. So 8 has to be here because it must be next to a 9. It must be less than a 9. So this is 8. This is 9. 9 cannot be here. Where is 9 in box 8? Can't be here because they have digits greater than it, so 9 has to be one of these 3 digits, which means 9 cannot be here, here, or here. 9 has to be one of these two. 9 can't be here or here. It cannot be here, so this must one of these two is 9. 9 is one of these 3. Okay. Remaining digits of column 2. We have 3, 4, 5, 6, 7. This digit is smaller than this, so this can't be 7, this can't be 3. This digit is smaller than that. This can't be 7, this can't be 3. This digit is smaller than that, so it has to be 2, 3, 4, or 5. Cannot be 1 because of 1 in the column. This digit is greater than this, so it's 5 through 8. Okay. This digit cannot be 1, so this must be 2 at minimum. 2 at minimum. So then we have 3, 4, 5, 6 at minimum. 3, 4, 5, 6. So this is the technique that I usually use on thermometers. This can't be 9, so this is 8 at most, 7 at most, 6 at most, 5 at most, 4 at most. This can't be 9, so similarly, 8, 7, 6, 5, and 4. So this has to be 2, 3, or 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8. Same with these. Do we have anything that differentiates these? Not right now. This has to be at least 3, 4, 5. This is at most 8, 7, 6. So 3, 4, 5. 4, 5, 6, 7. 5, 6, 7, 8. This is at least 2, 3, 4, and 5. This is at most 8, 7, 6, and 5. So it's 2, 3, 4, 5. 3, 4, 5, 6. 1, 2, 3, 4, and 5. This is 8 at most, 7 at most, 6 at most, 5, and then 4. 1 through 4, 2 through 5, 3 through 6, 4 through 7, 5 through 8. We have, where is 8 in row 1? Cannot be any of these cells, so 8 has to be here, which means this can't be 8, which means this can't be 7, no 6, no 5. Where's 2 in row 1? It has to be here. So this is 2, which makes this 1. So this can't be 1 here, no 1 here. Where's 7 now in row 1? It has to be here. So this is why I often like using these setups, I guess, to make this, to understand what things can be. Right? So 7 makes this an 8 here. Restrictions. Okay. Where are 1 and 2 in the central box? Cannot be here, cannot be here. And these two digits are greater than two other digits. So this must be a 1-2 pair here. This is at least 3, 4, 5, and 6. This is at most 9, 8, 7, and 6. So we have 3, 4, 5, 4 through 7, 5 through 8, 6 through 9 there. So now we're done with all the thermometers that we filled in. So we need to figure out some logic here. Okay. 8 eliminates 8 as a possibility here, so this can't be 7, this can't be 6. Where is 7 in column 2 now? Can't be here because of the 3, 4, 5, 6 quadruplet, so this is 7 here, which means this can't be 7 there. 8 eliminates a possibility for 8 there. No 7 here because of 7 in the column. Since this can't be 8, this can't be 7, that can't be 6. We are missing a 2 in column 8. So these cannot be 2, this can't be 2. Where is the 2? It has to be here, which means this can't be 2, so no 3, 4, or 5 there. Now, where's the 3 in column 8? It cannot be any of these cells here, so 3 has to be here. That means this must be 2 here. This can't be 2. This can't be 3. This is greater than that, so no 4, no 5. This is greater than that, cannot be 6, so this is an 8. Okay. Where is 2 in row 9? Cannot be here because of 2 in the box. Can't be here because of the thermometer. And so it must be here. So this is 2, which eliminates 2 here. This can't be 3 anymore because it has to be greater than that cell. Where is the 3 in column 2? It must be here. That eliminates 3 from being here, so this can't be 4, no 5, no 6. This can't be 2 because of 2 in the row, so this can't be 3, no 4, no 5, then because these must be greater than each of these respectively. Where is 2 in box 1? Can't be here, can't be here, can't be here, so it must be here. Where's 3? Well, we don't necessarily know that. Where's 3 in row 1? It has to be here. So that's 3. We have a 4, 5, 6, 7 quadruplet in row 6, which eliminates 4, 5, 6, 7 in the rest of the row. So we are left with 1, 2, 3, 8, and this cannot be 1, 2, or 3 because of 1, 2, 3 in the box. So that's 8. This is 1, 2, 3, 1, 2, 3, no 2 here because of 2 in the column. So 3 is in row 6, has to be one of these two cells, which eliminates 3 from the rest of the box, so this cannot be 3 here. That means this can't be 4, that can't be 5. Where's 4 in column 8? It has to be here, which must have a 3 less than it. So this is 3, which eliminates 3 here. So that's 4, 5, 6, and 7 to be continuously greater. 7, that makes this a 3. So this cannot be 3 here, which means this can't be 4. This can't be 6 because of 6 in the column, so this is 5, which makes this 4. And that 5, 6 eliminates 5 and 6 here, so that's 4. This can't be 7 because of 7 in the column. So where's 7 in row 6? It has to be here. So this is 7. Does that tell us anything? Not particularly. We know this can't be 5. Since this can't be 5, this can't be 6, because this has to be greater than this digit. Where is 5 then in column 8? It must be here, so therefore 4 has to be less than it. Remaining digits in column 3 are 5 and 6. Remaining digits in box 4 are 7 and 9. Remaining digits in column 9 then are 3 and 6. Remaining digits in row 8 are 3, 4, 5, 6. Now we have a guaranteed 3 in one of these two cells, because we have a 3, 4, 5, 6, 7 quadruplet, or quintuplet. This has to be 1, 2, and 9. And this cannot be 1 or 2, because 1, 2 in the column, so this is 9, which eliminates 9 here, so that's 1, 2 as a pair. That also eliminates 9 here. Where is 3 possible in column 6? Can't be here because of 3 in the row. Can't be here because of the way the thermometers work, and 3's in the rows. So 3 has to be here. This is 4, 5, 6, or 7. No 7 because of 7 in the box. We have a 4, 5, 6 triplet in column 6, which eliminates 4, 5, 6 in the rest of the column. So this must be 7. 3 is guaranteed to be one of these two, so this cannot be 3 here. It's 6, which makes that 3. 6 eliminates 6 in the rest of the row. So that's fine. Remaining digits of box 2. It's 4, 5, 6, and 9. So no 4 or 9 here, no 7 here. 3 eliminates 3 as a possibility here. We have a 4, 5 pair in box 8, which eliminates 4 and 5 in the rest of the box. No 4 here, that's 3. No 5 here, that's 6, which eliminates 6 from here. Where are 4 and 5 in box 5? Can't be here, can't be here because of the thermometer, so 4 has to be here, which forces 5 to be here, which makes this 6, which makes that 5. That leaves in box 5 the remaining digits 6, 8, and 9. And this can't be 6 or 8 because of 6 or 8 in the column, so this is 9, which makes this 8, which makes that 6, which makes this 5. That makes this 4. No 4, 5, or 6 here. It's 9. This can't be 4, 9, 5 or 9. It's 4. This can't be 4, 5. It's 6. 4 eliminates 4 here, so it's 5, which makes this 4. 8 eliminates the possibility from being here, whereas 8 in column 8, it has to be here. 5 eliminates 5 here, so it's 6. Remaining digits of row 7 are 6, 7, and 8. So this is 7, 8. This can't be 6 because of 6 in the column. So we have a 7, 8 pair in box 9, which eliminates 7 and 8 from this cell. So this is 6, which makes this 7, which makes this 9, which makes that 7. That leaves that as an 8. 3 eliminates 3 here, so it's 1, which makes this 2, which makes that 1, 2, and 1. This can't be 1 or 2, it's 3. We are left with a 2 here. This must be 6. 1 eliminates 1 here, so it's 9 and 1, which eliminates 9 here. So this is 9, and this is 5. 8 eliminates 8 here, so it's 7 and 8, which leaves this digit as a 7 and this digit as a 5. Thanks for playing. Thanks for setting. That was actually kind of interesting about how these interacted. Yeah, in the end, I did resort to the strategy that I normally do for thermometers. It just allows, for me personally, it allows me to visualize where things can and cannot be. So that's pretty helpful for me. I don't know if it's necessarily what helps everybody else. But for me personally, that's why I like doing that. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.